Okay, so 1.5, okay, finding inverses and parametric relations, horizontal line tests, to figure out if they're relations or not. Inverses. Alright, so 1 through 4, find the xy pair for the value of the parameter. Alright, number 2, we got x is equal to 5t minus 7.
What?
Y is equal to 17 minus 3t. For t is equal to negative 2.
You just plug in t? Oh, that's so nice.
Yeah, it's so easy.
Wait, this is the easiest thing we've done all year.
5 times negative 2 minus 7.
Until you add fractions.
So x is equal to negative 10 minus 7. So x is equal to negative 17.
I like it.
This is like a review of pre-algebra.
Yeah, go.
And y is equal to 17 minus 3 times negative 2. So y is equal to 17 plus 6. So y is equal to 23. And then you write your final answers in ordered pair, negative 17, 23.
Oh, that is so easy. We do not need to do any more of those. That is just...
You don't want to do any more of those?
I mean,
Depends
unless it
on
gets
what are
harder.
the numbers of the next one. So, yes, we do want to do the next
Just
Okay.
pick the next hardest one, and then...
4.
one.
There's only 4 problems in that particular section, so. Alright, x is equal to the absolute value of t plus 3. Y is equal to 1 over t. T is equal to negative 8. So x is equal to the absolute value of negative 8 plus 3. And y is equal to 1 over negative 8. So what is x equal to?
The absolute value?
Technically 11. No, what? Joel? Yeah,
5.
11.
It's 5.
Oh, 5, yeah.
The absolute value of negative 5, which means 5.
Yeah.
That was rude.
Okay, it's the absolute value of negative 5, which means 5. Okay, so, and then
Y.
for the y, the negative, just, it doesn't matter if it goes on the top or the bottom or just out front. So, ordered pair is 5, and then negative 1/8.
Love it. I think this is my
These
favorite.
problems are my best friend.
Can you
This
like
is
not
just-
sit there, Garrett? Because we're kind of headed in like the
Yeah, it
middle.
is looking at it.
It's still in the middle of the screen.
Okay, so can we also talk about...
Alright, next problem. Complete the following. Find the points determined by t is equal to negative 3, negative 2, negative 1, 0, 1, 2, and 3. Find a direct algebraic relationship between x and y and determine whether the parametric equations determine y as a function of x. Graph the relationship in the xy plane. I don't care about that. Alright, so we have x is equal to t plus 1 and y is equal to t squared minus 2t. So what you're going to do is you're going to make, for t is equal to, x equals t plus 1,
What?
y equals t squared minus 2t, and then whatever the xy pair is.
Wait, what happened?
We're going to make columns and fill this information in.
Oh.
I love it. Columns are fun.
Why is it C? It looks so much like a plus sign.
For negative 3, negative 2, negative 1, 0, 1, 2, and 3.
They gave us that, right?
Yeah.
Okay.
That's what they said they wanted it for.
We just saw each one. I love this. Love it.
Alright, so it's still really simple. You're just plugging each number in to its respective equation. So negative 3 plus 1 is what? Negative 2. Negative 2 plus 1.
Negative 1.
Negative 1. Negative 1 plus 1.
0.
0 plus 1.
And then it's like 1, 2, 3.
1 plus 1.
2.
2 plus 1.
3.
3 plus 1.
Wow, I'm so glad we can do basic math.
It looks like scary, but it's like super easy. Okay, and then y. So negative 3 squared
9.
minus 2 times negative 3.
Whoa, that is
It is 3.
I literally, why aren't these
That
numbers
minus
working?
6 is
Oh my
3,
gosh,
right?
that's 2 of them that don't work anymore.
Wait,
Negative
no.
2 times negative
It's
3 is
12.
what?
It's 12. Because it's
Negative 2 times negative 3 is what?
negative 6. I mean, positive 6.
6. What is negative 3 squared?
9.
9 plus 6 is what?
15.
Wait, 15. I'm stupid. Why did I say 12?
Alright, negative 2 squared is what?
4.
Negative 2 times negative 2.
4. 8.
Negative 1 squared
1.
minus 2 times negative 1.
Oh, wait, no.
It's 3.
0 squared minus 2 times 0.
0.
Oh, I'm losing where I am. 1 squared minus 2 times 1.
Negative 1.
2.
Negative 1.
Oh, my bad.
2 squared minus 2 times 2.
4 minus 8, so it'd be
No, it's
2 squared is 4.
it's
Eh.
0.
Oh, wait, no.
Right.
It's 4 minus 4, so it's 0.
I was putting 4 into the same.
And then 3 squared minus 2 times 3.
3.
And then now you just copy them over. The x, y ordered pair. Negative 2, 15. Negative 1, 8. 0, 3. 1, negative 1. 2, negative, or wait. 2, hold on.
0.
Yep, I can't read apparently. See, this is where I need lines. This is where lines are a problem. Come on, what is going on? 1, 0. 2, negative 1. 3, 0. And 4, 3. Also, I don't really know why I didn't write x, y in here.
Yeah, that's pretty easy.
Alright, so then part B says, that was part A. Part B says to find a direct algebraic relationship between x and y and to determine y as a function of x. So essentially, so again, this was part A. So part B,
There's another part? Oh, my wind. Sorry.
part B is essentially solve for t. Okay, so I've got x is equal to t plus 1. So how do I get t by itself?
We should
subtract
subtract
1.
So t is equal to x minus 1. So then now I want y as a function of x. That means that I'm going to get rid of the t's from my y equation, which was t squared minus 2t. So y of t is equal to t squared minus 2t. And anywhere I see t, I'm plugging this in. So x minus 1 squared minus 2 times x minus 1. So what does this x minus 1 squared factor into?
X
Wait, x minus 1 is what do you mean? X squared
2x
minus 2.
plus 1.
Okay, then distribute this part, minus 2x plus 2.
Oh.
So then you've got x squared minus 4x plus 3.
Why does mine look different like that?
So yes, y is a function of x. Because you have like y is equal to something that you know would be a function.
Is it always... Wait, are you going to do this again, but the opposite?
What do you mean?
So are you going to plug y into x?
No, you don't have to.
So is it always going to be that, or is it going to tell you?
What do you mean?
Like, are you always going to plug x into y?
No, in this case, like, so you're going to use whichever one of these is easier to get t by itself. This one would have been really difficult to get t by itself, so I used this one.
Oh, the chocolate is melting.
All right, and then just a thing to note here, parametric equations allows us to graph curves that are not functions. All right, so the next one you need your book out for, because we're going to look at the pictures. So these ones say the graph of a relation is shown. Is the relation a function? Does the relation have an inverse that is a function? So how do we tell if something's a function from a graph?
Vertical line test.
Okay, vertical line test. Okay, if it hits in 2 spots, is it a function or no? Yeah,
Wait, if it hits in
126.
2 spots, it's not a function, right?
Correct. Okay. And how do we tell if it has an inverse that's a function? Nope. It is a line test.
Horizontal.
Horizontal line test. Okay. So just quick refresher up here. Okay, horizontal line test. The inverse of a relation is a function if and only if each horizontal line intersects the graph of the original relation in at most one point. Okay. So, looking back here, okay, relations of functions. Okay, so here if we went across, okay, 1 passes the vertical line test, so it's a function. 2 does not pass the vertical line test, so it's not a function. 3 does not pass vertical line test, so it's not a function. 4 does pass the vertical line test. Okay, I realize my graph is kind of close here, but so it is a function. But then the ones that have inverses that are functions, doing the horizontal line test, so we go down. So 1 only ever hits in 1 spot, so it has an inverse. 2, okay, again going down, only ever hits in 1 spot. But both 3 and 4, okay, hit in multiple spots. So they are not, or they do not have inverses that are functions. So, number 10, we've got something that looks like that. Okay, so first we want to know if it's a function, and then we want to know if it is, or if it has an inverse that's a function. Okay, why is it a function? Okay, yes, because of the vertical line test. Does it have an inverse that's a function?
No,
Why not?
because it does not pass the horizontal line.
Okay, no, because of the horizontal line test. 12 is something like that. So is it a function? Okay, no, because of the vertical line test. Does it have an inverse that's a function?
Yes.
Okay, yes. Horizontal line test.
I like this chapter.
I don't like the chapter, but this section's pretty cool.
Well, this section of the chapter. Can I go for the roll on this?
Yes. Alright, so the next step says that we want to find a formula for f to the negative 1 of x, k, which means f inverse. So we want to find the inverse of the function. It says to give the domain. I'm not really worried about that part. I'd rather you just find the function. So with 14, we've got f of x is equal to 2x plus 5. Okay, or again, remember f of x can also be written as y, so I'm going to rewrite this, and you'll see why in just a second. Alright, so y is equal to 2x plus 5. Does anybody remember how I said you find an inverse? It may not have been written, but I probably said it. But I know that was a while ago, so if not, it's fine.
It's been like 3 weeks.
Yeah, I know. That's why I was saying it's...
You swap x and y, and then solve for y.
Swap x and y, and then solve for y. So x is equal to 2y plus 5. And now I just want to get y by itself. So how am I going to get y by itself? Subtract 5. So I'm going to go ahead and put my 2y on the left just because, you know, I'm going to ultimately want it there. So x minus 5. Then what?
Divide by 2.
Divide by 2. So y equals x minus 5 over 2. Okay, or you can write it as y is equal to 1/2 x minus 5/2. Okay, they both are the same thing. I'm okay with either form. Either one of those is, they're, like I said, same thing.
Yeah, that was nice. I like this.
You might not like the next one, but it's
Oh.
okay. It's not bad, it's just kind of irritating, I guess.
Ew, I see.
f of x is equal to x plus 3 over x minus 2. Okay, so again, remember f of x can be written as y. Okay, when you initially write down the problem, if you want to go ahead and write this as y instead of f of x, that's totally fine.
We're wearing our sweatshirts. We keep doing this. It's good.
I just put it
Well, I don't. I just wear it as a...
I looked and saw that it was cold and that it was going to be raining later and decided I was going to wear it.
Well, my thought process was we should wear our warm-ups on Thursday. And then... We're wearing them. And then we... Well, yeah. So, I figured...
Also, what
Well, I
time
mean, you
are
can wear a sweatshirt or...
There's a
warm-up.
bus to Portsmouth on Saturday, right? Do you know what time?
In theory, I don't.
So you guys get dismissed.
We don't even know when we're playing.
On
Never
Thursday.
mind.
Well, we do know when we play, but
Do you know what time?
1.
one. All
Wait
right.
a second. Never mind. Are we gonna try to get there early to watch the first game though, so we can like watch so much or no?
Maybe not like as soon as they start, but I'm gonna try to go like kind of early, but it also depends for sure if we have a bus or not, which is dependent on if Steven and Anna have a baby before that.
I hope they don't.
So, all right. So here, swap x and y. So x is equal to y plus 3 over y minus 2. Okay, you swap x and y, but anywhere there's an x, you've got to put a y. Okay, and anywhere there was a y, which should only ever be one place, you put an x. All right. Theories, philosophies on what I should do now. Because I need y by itself.
Could you multiply?
By what?
No. I was gonna say
Keep
y
change
plus
flip.
2, but that's a different thing. That's a complete
Wait, what if you multiply by the top? Bottom. So multiply it by y minus 2.
What are you saying to do?
Multiply the whole thing by y minus 2 over y minus 2.
That's going to give me a whole lot more y's than I want.
Well, I have no idea.
You're on the right track with what you said, with what we're multiplying, but not how I'm
What's
multiplying.
y
y
by
plus 2?
Negative 2.
Is it 3 and 2?
You just multiply the whole thing by negative 2.
Just by y. Really no.
Oh.
Where are the cheese balls in that come from?
I just multiplied this over here.
Oh,
I got confused. Sorry.
Okay, hold on, I'm getting a little out of focus, so we're gonna fix that.
my y's 2 different ways in this problem.
All right, so now what do you think we need to do?
Distribute.
Distribute first.
And then subtract 3.
X.
Nope, not yet.
I lied.
xy minus 2x is equal to y plus 3.
Can you subtract 3?
Nope.
Get y by itself, right?
Okay, I need to get, see how I have two y's and I have one on each side? I need to get them together, and I need to get anything without a y together. Okay, so I need my 3 and my 2x together, my negative 2x together, and then I need my xy and my y together. Okay? Let's launch my pencil. That was a problem. So I'm going to move this over here and this over here. Okay? So I'm going to have xy minus y is equal to 2x plus 3.
Now you divide by x.
Nope, you can't divide by x. I'm now going to, what's in both pieces right here?
Take out the y.
Okay, so I'm going to take out a y, so that gives me x minus 1 is equal to 2x plus 3. And now what? I need y by itself.
Don't distribute.
Do divide by x minus 1.
Divide by x minus 1, so y is equal to 2x plus 3 over x minus 1.
That's the answer.
Yep.
That's awesome.
Yeah, that one was a bit irritating.
Well,
All right. Let's see, we're going to do 2 more of this type. Were y'all asking if this was going to take the whole time because you have something you need to do?
I mean, yeah, I do, but like it's my fault for not doing it, so don't.
I'm just taking an L. I'm just gonna do
I
it
mean,
as
like,
an A grade.
If we have time, I'm gonna do something, but if not, I guess whatever.
Okay. All right, 18 f of x is equal to the square root of x plus 2. Okay, so again, this is y.
Oh no.
Swap x and y, so x is equal to the square root of y plus 2. Need to get y by itself.
Take the
Ideas.
square root. Square it. No, you square it. Y.
Okay, I have a square root being done to it, so I'm going to square it to get rid of it. So I'm squaring both sides. Okay, so I'm squaring and I'm squaring. So I have x squared is equal to y plus 2.
Then you subtract 2.
Okay, subtract 2, so y is equal to x squared minus 2.
Oh.
See, not bad, right?
Yeah, that's easy.
I have a quick
I like
question.
this.
I don't know how I did. Oh, well, no. I subtracted the x and put it on. What did it?
Huh?
Never mind.
What'd you say?
She changed her mind.
Okay.
changed
I just did not follow something with an x.
Yeah, my mouth wasn't working, but what happened
It's okay, that
was
happens to me a lot.
I moved y to the left and didn't just flip it, so I got negative y equals x squared minus 2. But if I have negative y, I have to divide it by.
That one was quite satisfying.
All right, 20 f of x is equal to the square root of x cubed plus 5.
Okay. So you again square it.
Okay, so hold on, I gotta swap first. So x is equal to the square root of y cubed plus 5. Okay, I need to square both sides to get rid of the square root. So x squared is equal to y cubed plus 5.
Now you subtract by 5.
Subtract 5, so y cubed is equal to x squared minus 5.
Do you take the cube root of it then?
Yep, so y is equal to the cube root of x squared minus 5.
And then you're done. Nothing like here.
And then I am done.
I'm chilly.
All right, I'm going to ask you guys what you want. I can stop here, and you guys can have the next 20 minutes to do whatever today. Or, assuming the bell doesn't ring like 18 minutes early like it's been doing. Or I can finish the examples. There's 1, 2, 3 more. One of them being really long, but the other 2 being relatively short. And I can finish them tomorrow, and then you can have whatever time is left tomorrow. Or we finish them now, and then you have all of class tomorrow to work on these problems. You have
I'm okay with whatever.
like 10 problems to do.
I'd say stop.
Yeah, I'll take it.
But can you give us the problems already from this section that if we don't need it, we can start working?
Yeah, clearly. We're working over here.
Alright, so to this point then. To this point, 3, 5, 9, 11, 15, 19, and 21. Okay, and then I'm only adding on like 2 or 3 more tomorrow. So.